Hello everyone, welcome back to my channel Expound AI. Here in this channel, I make a videos on implementation of machine learning and deep learning research papers and various projects. So today we are going to see how we can use Deep-Daze model for text to image generation. Basically, Deep-Daze is from OpenAI. I have written a blog for the same which you can refer. In this blog, we are going to see how we can use Deep-Daze model or how we implement this on Google Colab. So what I will do, I will share the link of the blog in the description below so you can check that out. So now let's get started. OpenAI present a neural network that is called CLIP, Contrastive Language Image Pre-training. It is trained on the wide variety of images with wide variety of natural language supervision that's available on the internet. I have mentioned the link of the official GitHub repository of Deep-Daze. Let me open that. This is the official GitHub repository of Deep-Daze. Here you can see the various examples that they have given. These are the text, and based on that the Deep-Daze has been generated those images. So this is the system requirement that they have mentioned. Below that they have given the installation process for the Windows. So you can install this on your Windows system as well. Below that, this is the command line tool which you can use in your system. So that's all. For more information, you can refer this repository. Now let's again come back to our blog. Now let's see how Deep-Daze works actually. Basically, Deep-Daze is simple command line tool for text to image generation using OpenAI's Clip and Siren. Now let's understand what is Clip. Research in the CLIP paper demonstrated that the simple pre-training task of predicting which caption goes with which image is an efficient and scalable way to learn state-of-the-art image representation from the scratch on the dataset of 400 million text and image pairs collected from the internet. Here they have used zero-shot transfer learning. So what is zero-shot transfer learning? Let's understand. So basically, zero-shot learning aims to recognize objects whose instance may not have been seen during training. Now let's take one example. Suppose someone would have no problem recognizing a zebra if he has seen a horse before and read somewhere that zebra looks similar to the horse but it has black and white strips. So this is how basically zero-shot learning works. This is just an overview about zero-shot learning. For more detailed understanding, you can follow the research paper link which I have given in the blog. Now let's see the overview of CLIP. Contrastive pre-training. Here, standard image models jointly train an image feature extractor and linear classifier to predict some labels. CLIP jointly train an image encoder and text encoder to predict the correct pairing of a batch of training examples. At test time, the learned text encoder synthesizes a zero-shot linear classifier by embedding the names or description of target dataset classes. For example, for classifying photos of dog versus cat, they check for each image whether a CLIP model predicts the text description, a photo of dog or the photo of cat is more likely to be paired with it. This is the performance comparison of CLIP with respect to ResNet 101. This is the datasets. So with respect to ImageNet, they have same accuracy or same score. With respect to ImageNet V2, it is increased by 6%. With ImageNet R, it is increased by plus 51%. With ObjectNet, it is plus 40%. With ObjectNet Sketch, it is around plus 35%. And with respect to ImageNet A, it is increased about plus 74%. So, this is just an overview of CLIP. For more detailed understanding about CLIP, you can refer this official research paper. You can also follow the official blog of CLIP. Now let's see Siren. It is a implicit neural representations with periodic activation function. It is a novel way to parameterize signal of all kind. Siren is a simple neural network architecture for implicit neural representations that uses sign as a periodic activation function. This is an image you can see. This is just an overview about Siren. For more info, you can refer this research paper. Now we are going to see how we can use Deep-Daze on Google Colab. This is the official GitHub repository of Deep-Daze. There they have gave the demo Colab file which we can use for inferencing the Deep-Daze. Let me show you that. So this is the notebook which we are going to use. Let me open. Okay, so this is the notebook which we are going to use for inferencing the Deep-Daze. Here we just have to install some dependencies, then we can use it easily. Now let's back towards our blog. So from here you can change the text whichever you want. These are some demo results which I have did. So now let's go towards the implementation of Deep-Daze on Google Colab. Now we are going to see the implementation of Deep-Daze on Google Colab. So first of all, we have to open the official GitHub repository of Deep-Daze. So let me do that. Now we have to copy this to our drive. Now we will connect. Okay, so now we will install all the dependencies which is required for the Deep-Daze. It will install all the dependencies and packages which are needed. Okay, so now we have installed all the dependencies without any error. Okay, so from here you can change the text. Basically, you can give any text, whatever image you want to generate. So right now we will try with silent road. So number of layers is equal to 32, save every is equal to 20. Means in every epoch there are 1050 iterations and after 20 iteration it will save the image. This setting you can change it also, but here we keep as it is. Image width is equal to 512, learning rate we keep as it is and the iterations also we keep as it is. Now the model train for the 20 epochs, but it will take huge time. So what I will do, I will just train it for the 5 epochs. So it will save our time. Okay, so now all done. Now we can start our training. It is started downloading the model. You can see that. Okay, iterations has been started. The first image has been generated, but we are not able to see anything or any kind of structure in this image. So we have to wait some epochs or some iterations. Now in this image we are getting some kind of structure. You can see that. Okay, so now here in this image, it has generated some kind of structure or shape, we can say that. Kind of road structure or kind of tree structure. So slowly, it is getting better. Here also you can see that we are getting much better result as compared to previous. Now what I will do, as you can see that it is taking huge time to generate the images. So what I will do, I will skip the video to the end of the every epoch and we will see the results directly. So let's do that. Okay, now you can see that we are going to complete our first epoch. So let's check the results. So let me scroll down. Okay, now you can see that image and you can compare with the first image which we have got. Now here we can clearly see the road structure, the trees, and it looks like a silent road. So we have a better result as compared to the previous. So now let's wait for the next epoch completion. Okay, so now you can see that we have completed our second epoch. So let's see the results. Let me scroll down a bit. So this image is much better as compared to the previous epoch. Here we can clearly see the roads and the trees. The overall structure also look like a silent road. So we are getting much better result as compared to the previous epoch. So let's wait for the next epoch. So here you can see that to complete two epochs it took around 1 hour. So it is little bit slow. So here we have completed our third epoch as well. So you can see that. So let's see the results. Let me scroll down a bit. Okay, so this is the image after third epoch. You can compare that with the second epoch. So it is better. So in every epoch we are getting better results. So let's wait for the next epoch. Okay, so now we have completed our 5 epoch. So this is how we started, and let's see the results what we get after 5th epoch. Let me scroll down a bit. Okay, so you can see that we have amazing results because within just 5 epochs we have getting better results or better images. This is great. For completion the process it took around 2 hours and 43 minutes. You can also download the images which has been generated. Let me show you that. Okay, so just to see the all the process or how we get started or where it stopped, let me show you the video of the all images. So that's all about Deep-Daze, how we can use that for text to image generation. I hope I'm able to deliver something. If you really like this video, please give thumbs up. And if you are new to my channel, please make sure you click that subscribe button for more interesting videos like this. Thank you for watching and happy learning.